Is my screen visible?
Yes, yes.
Okay. So here we are on the first question. The first question was pretty straightforward, and you didn't have to think too much on discussion. The question states you have to find the peak, and the peak is very much clear. The left and right numbers to the current number should be strictly lesser than the current number. So this number qualifies as a peak number. Okay. So there's nothing in this question. If we have three numbers, A, B, C, then B should be strictly greater than A and B should be strictly greater than C. If B qualifies these two conditions, then B is strictly greater number and B is a peak. Okay. And if B is a peak, we have to count in the index of B. Okay. So here we will quickly run through the example and see who all are peak index and store their value. So in the first example, we don't have any peak. You can see the first and last elements do not qualify for a peak. It is given in this problem statement itself. The first and last elements of the array are not a peak. So we'll leave the first and last element of the array and we'll iterate through the remaining part of the array, which is only this element. So as we can see, the left is smaller, but the right one is equal. So this can't be peak. So there's no peak in this array. So we'll return an empty array. Now coming to the next example, we'll leave the first and last elements for the peak consideration, as it is already given the first and last element of the array are not peak elements. Okay, so here we'll go from 4. Okay, so 4 is greater than 1 and 4 is greater than 3 also. So we'll take in the index of 4, which is 1. Now we'll go to 3. So both the elements to the left and right of 3 are greater than 3. So we can't take its index. We'll go to 8. Now to the left of 8, we have 3. 8 is greater than 3. To the right of 8, we have 5. And 8 is also greater than 5. So we can take in the index of 8, which is 3. And this is our answer. And yeah, we can return this array. One thing to take in notice is that whenever you encounter such question, you simply don't consider the first and last index. So you will run the loop as for int I is equal to 1 to I less than n minus 1. Notice the difference here. Usually what we do, we start our loop from I is equal to 0 to I less than n. And what we discussed here, that we don't have to take the first and last element to the consideration. And the first element is at 0th index. So we'll skip that and start from first index. So here's the case. And where's the last element? The last element is at n minus 1th index. So we are stopping just before n. Now we need to skip the last element. So that's why what we'll do, we'll stop just before n minus 1. So we'll do this. And some people don't do this thing, but I find this approach, like just straight away skipping the first and last element, a simpler way to avoid any kind of error. Otherwise you may encounter some kind of error wherein you are at the last element, you are at the n minus 1th element, and you are checking to its right, and there's no element to its right, and you can encounter an error. Is it clear, everyone?
Yeah, it's clear.
Okay, Vivek, you have doubt?
No, clear.
Okay, Tanmay, it's clear also.
Clear अभी.
Okay. So with discussion clear, we'll move to the next problem. The next problem.
ये मैं ये बोलना चाह रहा हूँ ना कि थोड़ा आप कोड करके बता देते ना तो ज्यादा बेटर रहता.
First question is pretty easy. I think you should try to code itself. And okay, I'll send the code also. But first you try. Okay. And
मैं भेज देता हूँ code.
okay. The
Chat पे.
first question is like you just have to iterate. Nothing more. Okay. Okay. So the second problem. We have discussed this problem before also, Tanmay and Vivek. Have we discussed this kind of problem beforehand also, Tanmay and Vivek?
हाँ.
Do you guys remember?
याद.
Vivek?
हाँ भैया.
Okay. So for this problem, what we'll do? Okay, how many among you were able to solve this problem? Okay, Tanmay was able to solve this problem. So, okay, first let's read the problem statement and then I'll move you to an example. Okay. And afterwards, you will yourself tell me the approach. I think the that's the way. That's the way. Okay. So the problem statement says minimum number of coins to be added. You are given a zero indexed integer arrays coins representing the values of coins available and an integer target. An integer x is obtainable if there exists a subsequence of coins that sums to x. Return the minimum number of coins of any value that need to be added to the array so that every integer in the range 1 to target is obtainable. Okay. So a subsequence is any non-empty sequence of the array which you can take. Okay. So I think the difference between subsequence and subarray is very much clear. Does anyone need any guidance with that? What's subsequence and what's an subarray? What's a subarray? Okay. So what I'll do, I'll take some examples. Let's take a simple example. Suppose we have got this array 1, 2. So what all sums we can get? Can we get 1? You can unmute yourself and speak.
Yes.
Okay. Can we get the sum 2?
Yes.
Can we get the sum 3?
Yes.
Yes.
So it's clear now. Next I'll write 4. Next I'll write 8. Next I'll write 16. Next I'll write 32. Okay. Now tell me one thing. Can we form all numbers? Okay, leave that question. So what all numbers can we found? We can form. Can we form the sum as 20? Can we form a subsequence whose sum is equal to 20?
Yes.
Can we form a subsequence whose sum is equal to 21?
Yes.
Can we form a subsequence whose sum is equal to 33? Okay. So let me now get you to the logic part. Okay. So here, what we are doing with the first two elements, we can form any number whose sum is from 1 to 3. We can form 1, we can form 2, and then again we can form subsequence whose sum is equal to 3 if we take both the numbers. Now we take first three elements. Let's see what all numbers can be formed.
1 to 7.
Okay. Now let's see. Can we form 4?
Yes.
We can form 4. That's clear. Can we form 5?
Yes.
Yes. We can take first two elements and then we can form 5. Can we form 6?
Yes.
Yes. Can we form 7?
Yes.
Okay. Now, what's the next number we cannot form from here?
8.
8. Okay. Now, if we take 8, can we form 8? Yes, of
Yes.
course. 8 is
Mhm.
a number itself. Can we form 9? Yes, we can take 8 and 1. Can we form 10? Yes, we can take 8 and 2. Similarly, we can form every number up to 15. So, I hope you are getting some feeling like where we are going in this solution. Okay. Now let me take some other example. With this, the approach will become even clearer. 1, 2, 4, 5, 7. Okay. Now, can you all tell me up to what sum can we form? Like from 1 to up to what sum? We can form every possible numbers. Is my question clear? Vivek, Chandan, Tanmay, is my question clear?
Clear, clear, clear.
Vivek?
Yes, clear.
So what's the answer? Okay, it's clear. What's the answer?
7.
20.
I mean,
Okay.
we can go up to like 7, 5, 12, 12, 19, but we cannot form like 1 to 19. That's it.
Yes.
Okay.
We can
Okay.
form 1 to 7. Every element in that
We
range.
can form up to 1 to 7.
Yes.
Okay. The
But we
maximum
can
we
also
can
go
get is
further.
19.
19.
Okay. Now let's see. What all sum can we form? 1, we can form easily. 2 is there, we can form easily. Can we form 3? Yes, we can form 3. Okay. Can we form 5? Oh, sorry. Can we form 4? 4 subsequence? Yes, there's an element 4 itself. We can take that and our sum will be 4. Can we form some 5? Yes.
Yes. Yes.
Can we form some 6?
Yes.
Yes.
Okay, we can, right? 2 plus 4 or 5 plus 1, we can form 6. Can we form some 7?
Yes.
Sure.
Yes. Yes.
Okay, 7, because there's an element 7 itself. We can take that and our sum will be 7. Can we form the sum 8?
Yes. 1 plus 7.
Okay, can we form the sum 9?
Yes.
Yes.
Can we form the sum 10?
10. Yes.
Can we form the sum 11?
11.
Yes.
11. Yes.
7 plus 4, it will
Yes.
be
Yes.
11. Can we form the sum 12?
Yes.
Yes.
7 plus 5. Can we form the sum 13? 7 plus 5 plus 1. 14. 7 plus 5 plus 2. 15.
10,
7 plus
4 plus
5. 12 plus 2 plus 1. 16. 7 plus 5 plus 4. 17. 7 plus 5 plus 4 plus
7 plus 5
1.
plus 16.
It is 16 only. 7 plus 5 plus 4. Now this is 17. Can we form the sum 18? Yes, we can form. 7 plus 5 plus 4 plus 2. Can we form some 19? Yes, we can form. 7 plus 5 plus 4 plus 2 plus 1. So we can form every number from 1 to 19. Is it clear now?
Yes.
Are you all getting the sequence? Are you all getting the pattern, the deductions which I am trying to give you all? Okay. Now, if you are getting that same intuition, let's move to the example. Let's get back to the problem and see if we can apply it here or not. Okay. Is anyone having any doubt? Then you can straight away ask. If anyone is having any doubt.
No.
Okay. If no one is having doubt, then we'll move to the problem. So, see, here's the problem. Example number 1. 1, 4, 10. We have got coins of denomination 1, 4, and 10. Clear? Now, can we form some 1?
Yes.
Yes.
We have coin of denomination 1, so we can form some 1. Now, can we form some 2?
No.
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 So we'll need to add this coin to our collections. So this is the first addition we'll need to do. So we'll need to add 2. So this is the number of coins we have added. So we have added 2. So we'll increment the add counter to 1 as we have added 2. Now we have added 2. So with 2, we can form some 2. We can form some 3 also. Now, can we form some 4? Yeah, that also we can form. Can we form some 5? 6?
Yes.
7?
Yes.
Up to 7 we can form. Can we form some 8? Can we form some 8?
No.
No, we can't form some 8 because we have till now 1, 2, 4, and 10 in our array. We can't use 10 to make the sum as 8 because if by any chance we include 10, our total sum will get beyond 8. So we can't include 10, that's for sure. So by using 1, 2, and 4, the maximum sum we can get is 7. We can't get the 7 as we can't get the sum as 8 because the maximum sum is 7 itself. Right? Clear?
Yes.
Yes.
So I hope that's clear. The maximum sum we can get with 1 to 4 is 7 itself. So we can't get our sum beyond 7 and we want to get 8. So it's not possible. We'll have to inject 8 into our array. So we'll inject 8 now and total additions we have done goes to 2 as we have added 8 now. Now we can form 8, we can form 9 also, we can form 10 also. Let's see what's the total sum of the array. Now the total sum of the array is 1 plus 2, 3 plus 4, 7 plus 8,
10,
15 plus 10,
25.
25. Now we'll be able to form every number from 1 to 25. And our target was to achieve all sums up to 1 to 19. And we are able to reach every sum from 1 to 25. Our target is achieved. We don't need to traverse any further.
Yes.
So here we can stop our operations. Now, if you want to see deductions, we can easily reach, but if you are curious, we can reach 25 by adding 10 plus 8 plus 4 plus 2 plus 1. We can reach 24 by just reducing 1 from here. Okay. Sorry. 10 plus 8 plus 4 plus 2. We can reach 23 by 10 plus 8 plus 4
Plus 1.
plus 1. We can reach 22 by further reducing 1 from here. So we can reach every sum. You don't need to take any issue, any tension for that. That all thing is taken care of. So we can form every number from 1 to 25 now. And how many additions we have done? We have done 2 additions. So 2 is our answer. We'll return that.
Okay.
Is it clear?
Yes.
Yes.
Now let's move to the third example. Third example, we have 1, 1, and 1. So can we form 1? Yes. Can we form 2? Yes. Can we form 3?
Yes.
Yes. Can we form 4? No, because we have got 3 elements and the sum of all the 3 elements is 3 itself. So we'll need to add further elements so that our sum reaches 4. Okay. Now which element you recommend me to add? Shall I add 1 or shall I add 4? Which element shall I add to this array?
4.
4 itself.
4.
Why? Because if I add 1, then my sum will become 4. That's fine. But for 5, again I'll have to add 1,
Yes.
right? So
Yes.
we want to do minimum addition. And for that, I'll straight away add 4 to this array. And as we have added 4 now, up to 7, we can form every single element.
Yes.
Okay, we can form 4, we can form 5, we can form 6, 7. Now, we can't form 8. Here, we'll need to add 8 to our array list. Now, our updated array is having 8 also. And we have done 2 additions till now. Now, till how much we can form the sums?
15.
15. Yes. We can form sums till 15. Now, after 15, we have to reach the target of 20, right? So what else we can add? We can add 5. If we add 5, we can easily reach to some 20, or ignore that thing. We straight away add 16 because we are not able to reach 16 here, right? So we'll add 16 here because we are able to form sums up to 15. So next unreachable is 16. So we'll add 16. Now after adding 16, up to what sum we can form by the use of the elements of this array?
31.
31. Yes. So 31 is more than 20. So we can hopefully form all the sums from 1 to 20 also. So how many additions we did?
3.
We did 3 additions. We added first of all 4, then we added 8, then we added 16, and now we can form all the sums from 1 to 20. So it's the answer. So is my approach clear?
Yeah.
Okay. So for this approach to work, or first let me ask Tanmay, uh, did you do with any other approach?
No, this approach.
You went with this approach only, right? So what's the first thing for this approach to work?
To optimize our calculation, we need to sort the array.
Yep. We need to sort the array. That's the first criteria. Second thing, we'll straight away iterate into the array.
Yes.
Okay. Let's see one more example. Let's see the unsorted example here. So here in this example, we have 1, we have 4, we have 10, we have 5, we have 7, we have 19. So here, first of all, can we form 1? Yes. Can we form 2? No. So we'll need to add 2 here. We'll add 2 here. And now we can form all the numbers from 1 to 3. Now can we form 4? Yes. Can we form 5? Yes. Can we form 6?
Yes.
Now how will you check? Because till now you have just iterated to 2 of the elements, and their sum at max can go to 5. But you also have this element 5 in the array, and you can form 6 by adding 1 and 5. So how will you check? For checking, your life will be easier if this array is sorted. If after 4 we are getting 5, if after 4 we are getting 5, then as we complete our traversal from 4, we'll move to 5, and as we move to 5, our total sum will become, sorry, we have added 2 also, so we can form all the sums to up to 7.
7.
Yeah, by this addition. But can we form the sum 8? Now the question is, can we form the sum 8? With the help of 10 we can't form, but if we have just 5 to the
Yes.
next of 4, we can easily tell that okay, I can form sum up to 13. And
No,
after
12.
5,
12 now. 1 plus 2 plus 4 plus 5. 7 plus
okay,
5.
okay, yeah. I just added to this 8. The sum is 7. So I can form all the sums from 1 to 12. Now I need sum 13. So for 13, when I'll move next to 5, if I get 7, then what will be my estimate? Up to what number can I aggregate these numbers to?
19.
19. And that was our challenge. Now we can form all the numbers from 1 to 19 with the help of these number. And how many additions we have done? We have done just one simple addition.
Yes.
So I hope that is clear.
Yes.
Is it clear, everyone?
Yes.
And for the code part, what I'll say, first of all, you'll need to sort this thing. Then you'll need to iterate through the array. If and constantly you'll need to maintain a sum. Okay. And this sum will actually represent the total sum of the elements you have till now. And next thing will be, what else do we need? Do we need anything else? No, we don't need anything else. You can say simply. So what we'll do? Okay. So let me pass you through a simple example here. Uh, let's move to this example. So we have 1. First of all, we'll add 1 to our sum. Now our sum becomes 1. Okay. Now we'll move to the next element, which is 4. Okay. Now next element is 4, and we have only 1 till now. So we can't form the sum 2, 3. Now for forming sum 2, what I'll need to add? I'll need to add 2. Okay. Now, am I clear with
Hmm.
whatever I'm saying? Or if you have any doubt, you can just ask in between.
Okay.
Okay. So what? Okay. So here I'm starting again. So I'll add 1. Okay. So next thing which I'll search is the sum 2. I should be able to form 2 with the help of the given elements in the array. Am I able to form 2? Can I form 2?
No.
No. So which number will I add now to the array?
2.
2 itself. So I'll add 2 itself, and my total sum will become 3, and total number we have added becomes 1 till now. Okay. Now we'll move to the next element, which is 4. Okay. Now we can form all the elements from 1 to 3. And now we are getting 4. So we can usually form, we can with guarantee form 4 also. With 4, we are getting the next element as 4. Now can we form 4 also with 1, 2, and 4? Hello?
Hmm. Still 7.
Yes, we are getting 4. Now our sum is 7. So we can form all the
7.
elements up to 7. Now after 4, we are getting 10. Okay. So I also need some 8 and 9,
8.
but I don't have any other element in the array which will help me in forming the sum 8. So I'll add which number to the array?
8.
8 itself. So my total sum will become
15.
15. And the numbers I have added to the array becomes 2. Now I can form all the sums from 1 to 15. Okay. Now I'll move to the next element, and the sum becomes 25. And I just had the target of 19. So I can form all the elements sum from 1 to 25. So my target is achieved.
Yeah.
So that's it. So Tanmay, if you can paste the code here, or otherwise I'll ask you all, recommend you all to code it yourself. If you are not able to
Yeah,
code,
yeah.
I'll put it later in the community section.
Paste that, yeah, भैया.
Okay, that's even better. So let's move to the next problem. So how many people were able to solve this problem?
नहीं हुआ ये.
Others? Okay, so no one was able to solve this problem. Let's begin up solving this problem. So here we have to count complete substrings. Okay, is it clear? Okay. Now let's move. Uh, Let me ask again. Was last question clear? Because there's complete silence. Was last question clear?
Yes.
Chandan, Vivek?
Yes, yes.
Yeah.
So I want all of you to spend at least 1 to 2 hours on every problem which you are not able to solve. That way you will have a better understanding in the class. And after this class, try try to write the code by yourself first. And if you're not able to solve, if you're not able to code yourself, then take hint from the recording. Okay. After hearing the approach, try again, because that way only your implementation will get strong. And by repeated trials, if you're not able to code, then you can ask again. We'll provide you with the code. Okay. So if your approach is very much clear, then try coding by yourself only. And if your approach is not clear, try hard to get that approach clear, because approach is very crucial. And if your approach is clear, then coding is another crucial part. And both of these things you have to get by yourself. It should not be like the logic is clear to me and coding is clear to me, implementation is clear to me. It should be clear to you. Okay, that's why I'm not presenting you the code right now. I am rather motivating you all to write the code who all were not able to write. And still, if you face difficulty, then you can ask in the next class or in the community. We'll provide you with the code. Okay. So the third problem of today's contest, you are given a string. Okay. Now a string substring s of word is complete if each character in s occurs exactly k times. Okay. Each character should occur exactly k times. You are given two things. One, a string, other, a character, other, an integer k. Now, every character in the string or any substring should occur exactly k times. Either it doesn't appear at all, or if it appears in the string, it should appear for k times. And we are not concerned about the order in which they occur. Okay. And the difference between two adjacent characters is at most 2. That is, for any at two adjacent characters, C1 and C2 in S, the absolute difference in their position in the alphabet is at most 2. Or you can take it in other sense as the difference between their ASCII characters should not be greater than 2. It can be at most 2, but not greater than 2. Is it clear?
Clear.
Return the number of complete substrings of word. The question is clear.
Yes.
Yes.
Others, Vivek?
Yes.
Okay. Now let's take some example and try to understand the things. Okay, for the first example, we have I, G, I, G, E, E. Okay, what's the absolute difference between the ASCII characters of I and G?
2.
A, B, C, D, E,
A,
F,
B,
G,
no,
H, I.
I. Yes.
So, absolute difference between their ASCII character is 2. Okay, so I and G can be adjacent element. There's no problem with that. Now, what's the difference between G and E?
2.
It is 7. It is 5. It is again 2.
Yes.
Okay. So, can G and E exist together?
Yes.
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 And now let's see what is K. K is equal to 2. So every unique character must appear
2
twice.
times. Yes.
Okay, exactly twice.
Hmm.
So which all substrings are possible? Which all complete substrings are possible?
IG, first one. Then
IG, IG,
IG, first one. Then double E,
then
second
double
one.
E.
And then IG, double E. IG, double E. Yes, IG, double E.
Can we form any other substring which is complete? Chandan?
Yes, it's okay.
Now I am asking, like, can we form any other substring which is also complete?
No.
No, no.
First of all the unique characters should occur exactly k times. K here is equal to 2. So here in this first substring, we have two unique characters, I and G. Both are occurring 2 times. Okay. In this substring, we have just one unique character, which is E, and E is occurring 2 times.
Yes.
In this substring, we have got 3 unique characters. Okay. And each of the characters is occurring exactly 2 times.
Yes.
Right? And apart from this, you can't form any other substring
Hmm.
in which every unique character is occurring exactly k times. Okay. So here this example was pretty straightforward. Now let me make this a bit complex. I G I G D D E E. Okay. Now tell me, what's the difference between ASCII value of I and G?
2.
2.
2. What's the difference between ASCII value of G and D?
E and the more than 2.
It
3.
is
3.
3.
3.
Okay.
So can these two elements exist adjacent to each other?
No.
No.
So can we take any substring in which G and D exist side by side?
No.
No.
No. So we can form all possible substrings of this part, and we can form all possible substrings of this part.
Yes.
Okay. But we cannot form a substring in which G and D are side by side, because if G and D come side by side, then we'll have two adjacent characters whose difference in ASCII value is greater than 2, which is 3 here. Clear?
Yes.
Okay. So, since this thing is very much clear to you all, I'll move to the next part. This is clear, right?
Yes.
Okay. If you have any doubt, you can ask in between, because this is a really very good question. Because otherwise, we have good number of submissions for the third question. But for this third question, we only had 500 submission during the contest. So if you would have solved this problem in the contest, you would have easily got a rank under 500, right? So this is a very good problem. Getting a rank under 500 is actually very good, right? In any of the coding platform, be it Code Forces or LeetCode or CodeChef, if you are getting a rank under 500 in Division 2 in CodeChef, Code Forces, or in LeetCode, then you are actually doing well, and you can be confident that I can solve any question of any interview or any uh, online assessment or offline assessment coding round. So I want all of you to be very much clear from the very beginning. Okay. So this thing is very much clear. Now let's move to the next part. Okay. So how many total substrings can be formed which are complete for this example? IG, double D, double E.
4.
Okay. Which are those? IG.
IG, 1, and then DD, then EE, then DDE. 4. Yeah.
Okay. So anyone has any other suggestions? Like, can we form any other substring also?
No.
No. So what is the first thing we'll need to do from here? We'll need to partition the array such that the difference between two adjacent character is not greater than 2. Okay. And if the difference becomes greater than 2, we'll partition the array, partition the string into different parts. Okay. So let me go again. IG, D, E. Now I'm traversing I. Okay. This is the first element. Then G. Okay. The difference is not greater than 2. Then again I. Difference is not greater than 2. Then G. Difference is again not greater than 2 with I. Now D. Difference is greater than 2. We'll simply partition it. Now IG is our first string. Okay. I'm not saying that this is a complete substring. Okay. It may happen that we get something even IG, say we get then GH. Okay. H, D. Okay. Let's take this example. Okay. IG, H, D. Okay. I, difference between G and I is less than 2. Difference between I and G again less than 2. Again we have G and I. difference is less than 2. We have then G and H. The difference between ASCII value of G and H is
A, B, C, D, E, F, G, H, 1.
H. It's 1. Okay. So G and H can also exist together.
Hmm.
Now, after H, we have
D.
D. Now, H and D can't occur simultaneously. Like
Yes.
they can't be adjacent elements,
Mhm.
adjacent characters. So what we'll need to do?
We need to make a partition between H and D. Make a partition between H and D.
Yes, we'll need to make a partition between H and D. Now, I'm not saying that the first partition is a complete substring.
Mhm.
Okay, some portion of the first partition can be complete substring, but I'm not saying that I'm partitioning on the basis of complete substring. I am partitioning on the basis that they are not compatible with each other, because H and D have difference more than 2. So they are not compatible o- for about existing with each other. So we'll need to partition them. Okay. Okay, clear?
Yes, please.
Now this part is clear. Then we'll move to the next part. Okay. So how do we check? How do we check? Suppose I have got this is clear, right? We are partitioning the string into multiple small substrings,
Yes.
and on what criteria? Such that no two adjacent character have difference more than 2,
What?
right? If we are getting difference more than 2, we are just separating them out, so that in a substring no two adjacent character have difference more than 2.
Hmm.
This part is clear.
Yes.
Others, Chandan, Vivek.
Yes, yes, clear.
Okay, now we'll move to the next part, which is again very crucial. Suppose I have got this partition IGIGH. Okay. Okay.
Yes.
Yes.
Now, how many unique characters we have here?
IGH, true.
We have, okay, let's talk in general. In general terms, it is given that uh, all the characters of the strings are lowercase English letters. Okay, it is given that the character are only lowercase English characters. So how many unique characters we can have?
26.
26. And what is matlab the longest word we can have?
ABCDFGHIJKL. Like that.
No, no, no. What is the longest word we can have? Like we have got 26 unique
4.
characters, and
Integer of 5.
longest complete word can be
Integer 4.
Represent
26 into k, such
Yes.
that we have got 26 unique character, and each character is occurring exactly k number of times. Is it clear?
Yeah, okay.
Others?
yes. Yes.
Clear, no?
Huh.
Okay. So this is the longest complete word we can have. 26 into k. Now, let's come here. Uh, let's come here. Okay. So let's say we want all the word, all the word in this substring. I'm talking about this substring, IGH, which has one unique character occurring exactly 2 times. Do we have any such instance?
Yes, IG.
No, I want only one character to occur 2 times.
One character to occur 2 times. IGI.
No, 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 sorry. So here see, DD. In this,
DDEE.
yeah,
Consecutive.
in DD, we have got two characters which are occurring exactly 2 times, and we have got no other character in our substring.
Yes.
Okay, so here we don't have any two adjacent equal characters, same characters. So in this scenario, it is not possible. Okay, let me uh, tell again. So I want one the good substring to be such that the good substring has only one unique character, and that unique character is occurring exactly 2 times. Okay, so
Hmm.
here we have I, but with I we have got G. No I is occurring twice. Okay, then we have got G. After G we have got again I, right?
Hmm.
So no
Yes.
G is occurring twice. Then with I we have got G here again, here
No.
again.
No I occurring twice.
Okay, now with G again we have H. No
G
G or
occurring.
H is occurring twice.
Hmm.
So we don't have any case where one unique character is occurring twice. Clear?
Hmm.
Now I'll check for the second case where two unique characters are occurring twice. Okay. Now here I don't want the two unique characters to be adjacent like DDEE. They can be in any sequence. Like I want a 4 letter substring in which we have got two unique characters, and uh, the frequency of both the characters is 2. Okay, it can be in any order. It can be A B B A, it can be A A B B, it can be B B A A. Okay, it can be A B A B, it can be anything. But in that substring I want exactly two unique characters occurring exactly 2 times. So I want exactly 4 length substring in which we need to have two unique characters, and each of them should be occurring exactly 2 times. Is it clear?
Yes.
Clear, everyone?
Yes.
Perfect. So let's check here. Let's check here. So here we have got IgIg. We have got IgIg, right?
Hmm.
In this, we have got two unique characters, I and G,
Yeah.
and both of them are occurring 2 times.
Hmm.
Okay. So yeah. we have got one complete substring. Now we'll choose another four length substring, which is GIGH. And I think this is very much clear how we'll transition from this. We'll use the sliding window concept, right? To update the frequency IGIG. Okay. In this window, we are currently in this window. Okay. We want to move to the next four letter word. So we'll just do what? We'll add the next character's frequency and reduce the first character's frequency we had till now. Clear? Hello? Is it clear?
Yes, clear.
We are using sliding window for that. And now in GIGH, we have got three unique characters. Now this fails our validation.
Hmm.
This fails our validation as we wanted only two unique characters. It is having three unique characters. That's it. We won't investigate any further. Now let's move to next scenario. We can't have any further four letter substring.
Yeah.
Right? Because we are already investigating GIGH. After this, we can't have another four length substring. Now, here, next I want three unique characters, and each of them should occur exactly two times in the substring. I am not concerned about the order in which they are occurring. There should not be more than three unique characters, and each of them should be occurring exactly k times. So the length of the substring should be 6, and the length of the substring is 5. So do we need to check? No, we don't need to check. So with this substring, we are getting exactly one complete substring. Is it clear?
Yes.
Now let's move to the other partition. Okay. Now let's move to the other partition, which is what?
DDEE.
Okay. I think all of you have not spent much time in solving the problem. That's why there's so much silence in the class. From next class, try spending more time on solving the problems. Okay. We'll take the next substring, DDEE. Okay. So I want all the substring in which I have got one unique character, and each of the unique character is occurring exactly two times. Clear? Hello?
Clear view.
Clear na? So I want in my substring there should be one unique character, and that unique character should occur twice. So what should be the length of that substring? 2. Because there is one unique character and it is occurring twice. So its length should be 2. Now let's check all the two length substring here. So first we have got DD.
Yes.
Okay, it's a good substring because in this we have got one unique character and it is occurring twice. So number of complete substring, complete or good, whatever it was, increases by 1. Now let's check another two length substring. It is DE,
character.
right? It is DE. Now here we have two unique characters. Okay.
Yeah.
So we'll just drop this because it is not a complete substring. Now we'll transition again. It is EE, right? EE. Now EE has one unique character,
Yes.
right? And it is occurring
2 times.
twice. Perfect. Now we got another complete string. And this, I hope everyone is familiar with sliding window. Anyone in the class who is not familiar with sliding window? Okay, if you are unfamiliar with sliding window, you can check our Arambh and Astitva batch. There we have discussed it in a complete detail. Like you won't need anything else after that for understanding any sliding window problem. So if you have problem there, you can just refer to that video because there we have spent 3 hours to discuss this thing. Okay, so this is simple, I guess. Updating the frequency, moving the sliding window, how we do all that, we have discussed in complete detail. So I won't go in much detail here. You can just refer to our those videos. Okay. Now we have check all the two length substring. Now let's move to next scenario where we'll have two unique characters and each character should occur exactly 2 times. Okay. So what should be the length of the substring? 4. So let's check the first 4 length substring. Okay. Here we have two unique characters. Hello.
Yes.
And each character is occurring exactly twice.
Yes.
Yes. So we got another complete substring. Okay. And do we have any other 4 length substring?
No.
No, because it itself is 4 length substring. If we move the window here, the window will go out of scope. We don't have any other 4 length substring. Now we'll move to the next case where we have 3 unique characters.
Occurring exactly twice.
Each character should occur exactly 2 times.
Yes.
Okay. So what should be the length of that substring? It should be 6.
6.
And here the length of the substring we have is 4 only. So we can discard this case. And the total number of good substrings we got is
4.
4. 4. Clear,
Yes.
everyone?
Yes.
So if this is clear, so what all we did, let me summarize this all for now. First of all, what we'll need to do, we will iterate into the array and straight away we can do partitioning, or you can do on runtime also, but we'll do partitioning. Like if any two characters have difference greater than 2 of the ASCII values, we'll partition those segment, that these two parties cannot be in the same substring. So if these two parties can't be in same substring, let's put a partition here. Now we'll partition the whole of the array like this. Now second thing, what we'll do, we'll check for one unique character occurring exactly k number of times, two unique characters exactly occurring k number of times, three unique character occurring exactly k number of times. Okay, we'll check for all of these cases for each substring, and then we'll reach our final answer. And we also discussed the break statements that you can cleverly put, and by the help of sliding window we can do all of this. Like we'll first like this, I think we have discussed in great detail. You can just use sliding window and your work will be done. And this good thing which we have got is we have got only 26 unique characters. So it will not be like too much. The time complexity will always be within our range only.
Hmm.
So you don't need to worry about that. First of all, you will need to partition the thing. And the second part, you'll need to do what? You'll just need simple sliding window. I think this is a very common sliding window problem also. A, B, C, D, E, F, G, H. Well, let's say it's any string, substring, and we need to find if all the character is occurring exactly k number of times. It is a very classical hashing or sliding window problem that you can do by yourself if you have some awareness about sliding window and hashing. And that too, hashing, you don't need to use any unordered map or ordered map. You can simply use,
Sequential.
yeah, you can simply use array, simple array, because here the number of characters is fixed. So I hope this approach is clear. And if this approach is clear, first of all, is this approach clear? Let me ask again. Is this approach clear?
Clear, clear view.
Others?
Yes.
Okay. So if this approach is clear, see, it's a very good problem. Only 500 people were able to solve this problem. So this is actually very good problem. So it will be very good if you try implementing this on your own. If you face any problem, take hint of the recording video of this class, of this lecture, and then try solving on your own. If you face any difficulty, you can ask. Okay, but try to understand this. Do dry run on pen and paper, then try implementing it. Okay, try to code it, and again, if you are facing difficulty, then you can ask. Clear?
Clear.
Okay, so this was a really very good question, really very good question. And it is not something which can't be asked, it can be asked. So you better prepare yourself for this kind of problem. Okay.
अच्छा भैया एक क्वेश्चन था, ये जो थर्ड नंबर वाला क्वेश्चन था, तो इसके लिए मतलब कितना टाइम देना चाहिए, मतलब अगर कॉन्टेस्ट में मिला तो, अगर हो।
In contest, this, I don't think this problem is a medium level problem, first of all. So this is a hard problem, good hard problem. Not uh, we have got some hard problems which are, I think, which can't be done in 1 hour. But this is not that hard. This is problem is not that hard. You can try solving this in 1 hour to 1.5 hour in the contest. This is hard, but doable hard. Like we were not using any tough approach, tough DFS or tough anything. We're say straight away using simple partitioning, simple sliding window hashing. Okay, but the thing was we were using all of them together. That what made this problem bit hard. Otherwise, all the concepts involved like sliding window, hashing, partitioning, these all things are easy, but all of them together combined became hard. So you should try to solve this problem within 1 hour or 1.5 hour, whichever time you have got in contest. And if you are not able to solve, it's no problem. Dedicate good amount of time to solve this. Try pen and paper, then try coding it. It will present good amount of learning.
ओके भैया।
Okay. So it was good, but you could have done this problem. And by the end of this 75 contest challenge, we'll try to ensure that your level reaches to that level. Okay. So Now next problem. Count the number of infection sequences. So how many among you have read this problem?
तो नहीं भैया, नहीं पढ़ा, छोड़ दो ये वाला प्रॉब्लम।
Okay. So Tanmay hasn't read this problem. Any other? Chandan, Vivek, you guys have read this
No,
problem?
no. I have not attended today. No.
Okay. So
इसका
okay.
सबमिशन कितना था भैया?
It was a good problem. Only 200, less than 200 submissions. Okay, now what we'll do, I'll give you a hint of this problem. Okay. And we'll discuss this problem on Tuesday. Okay. And by that time, what you all do, you attempt this problem based on the hint.
थर्ड क्वेश्चन, थर्ड एंड फोर्थ क्वेश्चन।
Right. So suppose here we have got uh, suppose we have got n, and then we have got an array. We have got some people from 0 to n minus 1, and out of all the people from 0 to n minus 1, some people are infected. Okay, now you'll need to find what are the total number of unique infection sequences we can have. Like for this case, we have got n is equal to 5 in the first example. Okay, clear? N is equal to 5.
क्लियर।
So this means we have people from 0 to 4, 0, 1, 2, 3, 4. And out of these 4, we have got person on index 0 and index 4 infected. Okay, so these two are infected, and you need to find the infection sequence. So at a time, what can happen is that if 0 is infected, 1 can get infected, or 4 is infected, so 3 can get infected. And at a time, only one person adjacent will get infected. Okay, so what can be the infection sequence? It can be after 0, 1 get infected. Okay, 1 is now also infected. Now after 1, either 2 can get infected or 3 can get infected. Suppose 2 gets infected. Now after 2, only 3 can get infected. So this is one possible sequence. Now another possible sequence. First of all, 1 gets infected. Then after 1, either 2 can get infected or 3 can get infected. So this time, let's say 3 gets infected. Now in the end, we have only 2. So 2 gets infected. Now next possibility. 3 gets infected, then 2 gets infected, then 1 gets infected. Now other thing, 3 gets infected, then 1 gets infected. After 3, can 1 get infected? Yes, 1 can get infected because 0 is beside 1, which is infected. So after 1, what can happen?
2 get infected।
2 can get infected. Can we have any other sequence?
No।
No, we can't have any other subsequence because see, here we 2 can't get infected in the first place. Either 1 or 3 need to get infected first. So we exhausted all the possibilities of starting with 1. Then we exhausted all the possibilities of infection starting from 3. So we can't have any other possibility. So this is a simple permutation combination problem. Oh, simple. It may not be simple for all of you, but if you were familiar with permutation and combination of JE, then it is not that hard. Suppose we have got suppose this is the case. Okay, this is infected, this is infected. So For next infection to spread, how many options we have?
How many options?
In next time, yes,
Three, three, six.
either this person get infected, or either this person can get infected. Do we have any other option?
No.
No. So we have two options. Now suppose either this person gets infected or this person gets infected. Suppose this person got infected.
Hmm.
Okay. Now for the next step, how many options we have?
For the next step, we have one option.
These two
Options.
these
Two
two are already infected. This is already infected. These two
options.
are remaining.
Yeah.
So how many options do we have?
Two options.
Two options. Now suppose out of these two, this got infected. Now how many options do we have?
Then also two options.
We have got only one person.
Oh, I think that one, third one and fourth. Okay.
No. So we have got only one option. Now, next, let's take this example. Okay. So these two are infected. These two are infected people.
Hmm.
For the infection to spread, how many options do we have?
Two.
It can either spread to this person or to this person, right? How many options do we have?
Two
Only
options.
two options, no? Either it can spread to this person or to this person. Do we have any other possibility?
No.
No, right? So suppose this person gets infected. Now we have 3 uninfected people, right?
Yes.
Now for the next time, for the infection to spread, how many options do we have?
Three.
3.
Yes.
These two are infected. This is infected. Okay. So next, this person can get infected or this person can get
Oh,
infected.
sorry. Two.
We again have two options. Now suppose this person got infected. Now we have got two uninfected people, and this is infected. This is also infected. Now how many options do we have?
Two.
Still two. Okay. Suppose this person got infected. Now we only have one person. How many options do we have?
One.
One. So if you go by these deductions, you'll find out that if we have got some spaces between two infected people, suppose we have got 3 spaces here. So what we did 2 to the power 3 minus 1. Here between two infected people we had 4 spaces. So what we did 2 to the power 4 minus 1. So you can go by this approach and check. It will come true always. If we have got say n spaces between two people, then the number of possible ways will be 2 to the power n minus 1. Okay. If it is not coming intuitively, you can use pen and paper to get to this approach. It is actually good J level maths problem. If you are not comfortable with permutation and combination, you can check out our Astitva video. I guess therein we have discussed some of the permutation combination, and some part is also discussed in no, I don't think in Prachand we have discussed. We have discussed it in Astitva phase, right? Tanmay and Vivek?
Yes.
Yes, Dev.
Yes, we have discussed permutation and combination in great detail there. So you can refer to
Astitva.
those videos. Astitva phase. So you can refer them. Okay. So yeah, if you refer them, you will understand this permutation thing. So if we have got n spaces between two infected people, then what is the total number of infected people we can have? What is the
करो
total combination of infected sequence we can have? 2 to
तो
the
करो
power n minus 1. Now suppose we have got different subsequences. I 4i, then 3i, then again 3i. Okay. So these all are independent cases.
Okay.
These all are independent cases, right? Suppose this is getting infected. Okay. Then this is getting infected. This is getting infected. So these are all independent of each other, right? Whatever happening here won't affect what is happening here, right?
Yes. Yes.
But in a partition, what is happening here will affect what is happening here,
Hmm.
right? But what is happening beyond two infected people won't affect what's happening in between them. So these all can be treated as isolated cases. And this again boils down to a very famous PNC formula, uh, which I will leave for now, but we'll discuss in the next class. Next class will be a short one, wherein we'll discuss only this approach, this problem. Okay. Or maybe in the discussion of the next class, we'll discuss this first and then next contest. Okay. So spend good time on this problem and on solving the third problem, which we discussed just sometimes back. Okay.
Okay.
So this contest was really good.